Yeah, very good evening. I'm audible.
Yes, sir, audible, sir.
Okay. Slide is visible, please. First slide. Title slide. Slide is visible, please.
Yes, sir, visible,
Okay,
sir.
thank you. So today we'll solve lots of problems from the your first class to maybe up to 10th week. So we'll wait within. We'll start within 5 minutes. Let us wait for if anybody is joined. So let us start. So welcome all in the hydraulic engineering PMRF TA live session. So today I am going to take the extra session, 2 hour extra session, and we'll solve today lots of questions. I'm Om Prakash Maurya from IIT Guwahati Department of Civil Engineering. So the first question is what is the correct expression for the hydrostatic pressure? That is hydrostatic pressure at a point within a fluid at rest, and given
Sir,
the
please move the slide, sir.
slide is not visible. Not moving, you are
First,
telling?
first. Okay, sir. Okay, sir.
Okay, okay. Now it is okay. Okay. Let me share. I think entire screen. But if you, I see. Okay, I think it's okay. No problem. Okay. So the fluid density is given rho. Fluid density is rho is given, and the gravitational g is given, and h is given. So here, what is the hydrostatic pressure? So which option is correct? Please try to give the answer very quickly. Option A is equal to rho ZH. Option B is rho H by Z. Option P is equal to GH by rho. And option C and option D is equal to H by rho Z. So which option is correct? If the question is, if water is in the static condition, there is no velocity, as well as if the water is moving with very constant velocity. So let us suppose this is the H depth. So here is the your pressure. What is the pressure? So P is equal to what? You know already from your, this is a very basic question. Okay. So the first option is correct for that, rho GH. Definitely. It will be the density of water into your acceleration due to gravity and the height of rho GH. Now moving ahead on the next question. Next question is, what is the condition for fluid static to be applicable in a system? Fluid statics we are talking about here. Remember, a fluid must be incompressible, a fluid must be moving at a constant velocity, a fluid must be in viscid, option C, and option D is fluid must be at rest or moving with a constant velocity. What is the condition for the fluid static? So if you know, please you can reply in the chat box whether option A, B, C, D correct. Just you need to write A, B, C, D. Or you can also use your mic for the answer. No problem. So the answer of this question is D. Your fluid must be rest as well as moving with a constant or moving with a constant velocity. This is the condition of static. That is, your force will be zero. If the moving with the constant velocity, acceleration will be zero, then force will be also zero. It will come under the static. Okay. Now, what is the name of a device used for measure the fluid pressure in a system? Whether it is manometer, barometer, hydrometer, and the thermometer. Which one is correct? Option A, B, C, D. If you please know, within 1 minute you try to tell. Okay, manometer, that's good. Manometer will use for the fluid pressure measurement in the system. Option A is correct for this question. Now next question is, what does Pascal law state in the fluid mechanics? Pascal law in the fluid mechanics. So option A is pressure increase with depth in a fluid at rest, that is P is equal to rho ZH here talking about. Another, pressure remain constant in a fluid at rest, option B. Option C, pressure is inversely proportional to the velocity in fluid flow. Pressure is inversely proportional to the this is and pressure remain constant if the static condition, that is your velocity, will be 0, or acceleration you can say will be 0. Or option D is pressure applied to a confined fluid is transmitted undiminished to every point within the fluid. Which option is correct? A, B, C, D. Whether so for this question you are talking about option number A is correct or previous question? So option A you have you are telling the option A, whether for this question or the previous question, because you have written here the 2 AA. Okay. So for this question actually option D is correct, because the first option is what? It is the definition of the hydrostatic pressure, or it is the expression for the whatever the here written. This is known as the hydrostatic pressure distribution. And the pressure remain constant in the fluid static, because the pressure not remain constant because it will be increased with the depth, and the pressure is inversely proportional to the velocity. This is not the Pascal law, and option D is correct for that. Whatever the pressure applied on a fluid, it will be transmitted to the every point within the fluid. It means what? Actually, if your let's suppose if such type of your body is there, and let's suppose it is confined, let us suppose here one point, and at the same level we will select another point at the same level. If we, and the all is water, H2O, at the same level we have selected another point. So if whatever the pressure at that level will be at, let's suppose pressure here is depth is H, this is point A, this is point B, C, D, E. So if here is the, if H rho GH, so everywhere your pressure will be rho GH. Whether if it is like that, here some obstruction, your pressure will be rho GH. There is no difference if it is at the same level. This is the actual meaning of your Pascal law. Now, what is the principle of buoyancy? Yes, this question. What is the principle of buoyancy in fluid mechanics? Option A, objects submerged in a fluid experience an upward force equal to the weight of the fluid displaced. Option B, objects submerged in a fluid experience a downward force equal to the weight of the fluid displaced. Option C, objects submerged in a fluid experience a force proportional to the depth of submergence. Option D, object submerged in a fluid experience a force proportional to the density of the fluid. Whether option A, B, C, D, which one is correct? Please try to give the answer based on your whole experience of fluid mechanics. Which one is correct? A, B, C, D. Within 1 and 2 minutes, please try to give answer. Otherwise, I will tell the answer. Okay, you are telling the option A is correct. Yes, option A is correct for that question. For this question, option A is correct. Definitely. Object submerged in a fluid experience an upward force equal to the weight of fluid displaced. Based on this principle, we'll solve one question. I have one numerical type question. Now, next question is what is the name of phenomenon where the fluid flow is smoothly in parallel layers within a minimal disruption between the layers? Meaning here flow will be layer wise. In the zoom view I am showing here very smoothly. So whether turbulent flow, laminar flow, transition flow or the viscous flow. Yes, definitely it is a laminar flow. Okay, you are telling the option B. Yes, definitely it will be the answer will be B for this question. Now next question is what is the Reynolds number used for the fluid mechanics? To measure the pressure gradient in fluid, to determine the velocity profile in a fluid, option C to predict whether the flow is laminar or turbulent, option D to calculate the hydraulic radius of channel. Which option is correct for that? Whether A, B, C, D or maybe two option will be correct also. So please give the answer very carefully. For this question you are telling option D is correct, B and D. Okay. No, actually you are a bit confused. We calculate the hydraulic radius is nothing but hydraulic radius is, if I am right like that, or hydraulic mean radius, it will be represented by R, weighted area by weighted perimeter. It is the function of what? It is the function of your geometry, not the flow behavior and everything. So you basically we use the Reynolds number for the predict of the laminar and turbulent flow. Only C option is correct for that. Velocity profile will not calculate using the Reynolds number. So we just try to get whether it is laminar and turbulent. Option C is correct for that. Now moving ahead on the next question. Which of the following is correct expression for the velocity profile in laminar flow through a circular pipe? Let's suppose one circular pipe is, let me draw a circular pipe, and I want to measure at this section the velocity profile u, velocity in this direction, and in this direction your depth, in this direction is u. So what is the profile for that? Whether parabolic, linear, exponential, or the irregular, and flow is laminar. So you are telling the option A is correct. Definitely option A is correct for that. If water will flow turbulent, what will the condition? I will just tell you. Definitely in case of the parabolic, so after the development, these all question we are discussing here after the development length. So after getting the development length, or when the flow you developed fully developed flow, after that your flow, that is the velocity diagram, will be parabolic in the pipe, not like that, parabolic. Remember always parabolic. So before development, what will happen? Before development, your knot will be completely parabolic. It will be like that. Here it will be like that. After some distance, your boundary layer like that. Here your boundary layer like that. Here is the straight part. This is the straight part. After that, this is the maximum point of the velocity vu max, and if you will take the average, here it will come around the average part here. So your the u max is 2 times of the u average. Remember, in case of the pipe flow, if the flow is turbulent, this is the case of laminar. Okay, if the flow is turbulent, what will happen? So in turbulent flow, your velocity diagram is look like, let me draw first. Same section I am taking here. Little bit straight, little bit linear here, little bit linear. That is the sharp change in the gradient. After that, it will be behave like uniform, like that. In case of turbulent, always remember. This is the basic question. So here is the 3 layer. First layer is in between. You have 3 layer. First layer is your, here I am not able to draw. So this is your viscous layer, then buffer layer, and after that transition, and after that your turbulent layer. If we will draw here the midline, similarly above. So in case of the turbulent flow, we have the 3, we actually try to divide. Actually turbulent flow having the lots of eddies. So for studying the turbulent flow, we divide the velocity profile in the 3-4 part. 3 part, the viscous layer part, buffer layer part, transient part, and the turbulent part, and we try to study based on that only. So why we are dividing? Because of the analysis of the, because it's a very chaotic motion. In turbulent, lots of eddies forms. Always turbulent flow having the eddies. So we cannot analyze analytically. So try to divide the velocity layer in the 3 part, 4 part, and based on that we analyzed each part. So in the below, here below is your velocity behaving linearly, and above your velocity behave in the turbulent zone logarithmic. Remember, not parabolic. Okay, now moving ahead on the next. Okay, next question is what is the correct equation for Bernoulli principle in fluid mechanics, neglecting viscous effect and external forces? Here, your first option is P plus half rho V square plus rho GH. Second option P plus half rho V square rho G by H. Option C P plus rho V plus rho GH. Option D P plus half rho V plus rho GH. Whether option A, B, C, D correct? Please try to give the answer within 1 or 2 minutes, and then after I will explain little bit here more. So one thing is always, what is happening? Ratasri, I am audible? Please wait for few minutes because I have some network problem I think in my laptop.
Okay, sir.
Okay, okay, please wait. I have just joined my with mobile, so please wait few minutes. Network issue is happening. Let me use the mobile. Okay, now it is visible. Question? The question is visible, please.
Yes, sir, visible.
Okay. Okay, the answer of this question is, let me discuss. Okay. So you know already your the Bernoulli's very famous equation is P by rho z plus V square by 2z. In this format you always very handy with this form is constant. So, or you can say here the constant also. So in this format if you will try to calculate, if option A you divide rho z, so P by rho z plus half rho V square divided by rho z plus rho g h divided by rho z. So here rho z cancel, rho is cancelled, not g is cancelled, g is here. So P by rho z plus V square by 2z plus h is equal to here constant by rho z. Rho z is also constant, so again another constant C1. So option A is correct for that. Now moving ahead on the next question. Next question is, what is the equation of motion for an inviscid fluid? We are talking about here the equation of motion for inviscid fluid expressing the conservation of momentum. So which express the conservation of momentum, whether it is Euler equation, Navier-Stokes equation, Bernoulli equation or the continuity equation. The equation of motion for inviscid fluid. This is the main thing. So please, whether the option A, B, C, D, which one is correct, try to give the answer very quickly. Okay, you are for, I think for previous question you are telling option A. For this question, which one is correct? Whether option A, B, C, D? You are telling the option C is okay. Actually, for this question, option C is not correct because C is what representing. It's definitely it is derived from the your Euler equation, and but for here we are talking about the your only inviscid fluid, not because this equation having lots of assumption. Inviscid fluid as well as fluid should be incompressible, fluid should be steady, like that type of, but in this question this type of information is not there, and Euler option in the option Euler equation is there, so we will go for the best option. The best option is here A, so option A is correct for that. If the similar question, here we have talked about the viscid, that is your viscous fluid. If the fluid is viscous, then your Navier-Stokes equation will be the your correct option for this. But here is the inviscid, definitely we will go through the option A. Option A is correct for that. Now, what is the correct form of Navier-Stokes equation of an incompressible fluid? Remember, please, here rho is constant. So A, B, C, D. Which one is correct? Navier-Stokes equation. For your simplicity, let me write the Navier-Stokes equation, then you will, maybe you are able to give the, in the x direction I am going to write. Yeah, this is in x direction, your velocity is u. So this is u plus del u by del x v del u by del y plus w del u by del z equal to minus 1 by rho del p by del y del p by del x plus mu your del x del u square del y square plus del u square divided by del w square minus here plus your gravitational force. So based on that, if you will try to give answer, then you can definitely will select the whether option A, B, C, D. If you are able to write from the Cartesian to the vectorial form. If you will write this equation in the vectorial form, definitely you will get the answer. Please try to give, otherwise I will explain how I will write in the vectorial form. Okay, no problem. So here we have the x direction and also in y direction your Navier-Stokes equation del v by del t. Similarly everywhere here will be v, here also v everywhere. In z direction your everywhere will be the w del w by del t. So we have the three equation in x direction, y direction and the your z direction. So we can write all three direction equation in a single form using the your vectorial form. How? Your v vector, if you will write v vector is ui plus vj plus wk. Your del is equal to del by del x I plus del by del y j plus del by del z k. and you know that if you will multiply this thing I will be fine. If other I j, it will be 0, I k, it will be 0. So I into I is equal to 1, I into j will be 0, like that. So remember, so like that your this three thing u, v and w, if we write these three things as a del v vector divided by del t, it will be fine for 3 plus these things u, v, w. If we will write v dot your del, if you will do these things v dot, if we write here dot everywhere, your v dot what, u, v, j and I will multiply here, it will come u, v and w. So like that you can write, and this vector is again when you will multiply, this will be like that. So here you can also, because here u, v, w is also there, so like that. Now is equal to, here del p by, you can write here all, because in x direction, y direction and z direction, for all three direction you need to write del by del p. Okay, here x is there also. Now this one rho mu, definitely it will come like that mu, and here is your del. How we will write this? When you will square these things, everywhere will come the square, so this square is there, and your v is, u is there, v vector is there, that is v vector here, this is a v vector. So I, j, k will be involved in all these things. So when you will multiply, you will get these things, del square u, and your body force, you know already, g is also the vectorial things, gi plus gj plus gk. So I will get also. So option A is correct. Using this, if you want to more information like that, you can go through the some classical book. Also, you will follow some material on the also available on internet. You can go easily. You can get how you will convert these things. Now moving ahead on the next question. What is the correct form of continuity equation for an incompressible fluid? Here incompressible fluid, rho is constant, and we are talking about the continuity equation here. So whether option A, B, C, D, which one is correct for that, for this question? So please try to give the answer. So your continuity equation will be this one, because you know already for incompressible fluid we are talking about so whether option A, B, C, D is correct. For this question, option A will be correct for this question, because if your flow will be steady flow, then what will happen here? You will get this term will be not there. But here not the steady flow, then option A will be correct for this question. Now moving ahead on the next question, what is the correct expression for Reynolds number Re in fluid mechanics? We are talking about here the Re involving characteristics length L and velocity u, V here representing the velocity V, and the dynamic viscosity. So what is the actually Reynolds number? And I will tell one good thing here about the Reynolds number. First you will try to give the answer. And Reynolds number you know already is the dimensionless number. And we always, as a hydraulic engineer, we try to non-dimensionalize everything because we can compare very easily, but sometimes not possible for everything non-dimensionalization, but sometimes it's very helpful. So this is the non-dimensional number. So now what is actually rho VL is the characteristics length by mu. You know already kinematic viscosity is what? Dynamic viscosity divided by rho. So this equation you can write like that also. So your Re will become VL divided by, this is the characteristics length. Remember here mu. So if you will see, actually Reynolds number is nothing but, here is meter and below is also in numerator and denominator is the unit is meter. How? Let me show you. Re is equal to here meter per second into meter divided by meter square per second. So these things I want to write here, meter per second. Is it okay? No problem. So what is remaining? Meter divided by meter square per second divided by meter per second. When you will cancel out meter by meter. So here for non-dimensionalizing the Reynolds number, we'll use what? Your kinematic viscosity divided by velocity. This is a non-dimensionless number, and no, this is this mu by velocity is having the unit meter and length is having the unit meter. So your Reynolds number is what? Reynolds number is a length problem. Remember, somewhere we need to utilize this concept. For non-dimensionalizing the things, we need to multiply or divide by these things. Always remember, when you will do the higher study, you will get these things. But remember. Now, next question is, what is the correct expression for Darcy's-Weisbach equation? Correct expression for Darcy's-Weisbach equation describing pressure loss in laminar flow through pipe. Pressure loss, laminar flow through pipe. Flow is laminar, that is your Re is what? Less than or equal to 2000, somewhere it is written 20, 100, somewhere it is written 23. Don't be confused in case of the pipe flow. So your delta P is what? In Darcy's-Weisbach equation, that is your head loss delta P is nothing but P1 minus P2 or an HF, you know already, your delta P by O. Remember? Now you can guess the answer for this question. Whether option A, B, C, D, which one is correct? Anybody's join? I think not. So the answer of this question is, if I write very quickly, you know already HF is equal to FLV square by 2ZD, but here HF is equal to delta P by rho. Your rho will be this side, F rho LV square by 2ZD. Actually here rho G, remember. So here it will also be. So G will be cancelled. FLV square by 2D. So option A is correct for that. Head loss is nothing but HF is equal to P1 minus P2 divided by rho Z, in between two sections. If you will take the two sections, section XX1, section X2, and we will write the Bernoulli's equation P1 by rho Z V1 square by 2Z plus Z1 and plus P1 by rho Z P2 by rho Z plus V1 square by V2 square by 2Z plus Z2, because at the similar height Z1 Z2 will be 0. So when you will calculate, you will get the answer like that. Now moving ahead, you will also need the continuity equation for that. Now what is the correct expression for Hazen-Pauli equation? Hazen-Pauli equation describing the laminar flow through a pipe. Whether option A, B, C, D, which one is correct? Pi d4 by 128. Now it is visible. 128 mu del P by L. Option B, Q is equal to pi d4 32 mu del P by L. Option C, pi dq divided by 128 mu del P by L. Option D, pi d cube 32 mu del P by L. So please try to calculate. Try to actually, I think you have to remember these things, because you can get the expression like that in your final exam or sometime numerical based on that. So your option A is correct for that. Remember always, Q is equal to pi d4 divided by 128 mu, like that. Now what is the correct expression for drag force FD? Acting on a sphere of fluid flow, acting on a sphere in a fluid flow, given the fluid density rho, sphere radius r, velocity u, and the drag coefficient CD. A is here the surface area. Now you can guess the answer. So you can guess the answer whether which one is correct. Anybody's why? Still I think no one. Whether A, B, C, D. So your option A is correct for that. Now the question is, what is the correct expression for the pressure distribution Pz in a fluid at rest in terms of fluid density rho, gravitational acceleration g and depth z. Here depth is given z. So again rho gh, or at the place of h you can write the rho gz, but here one extra term is there, P naught. P naught is nothing but P naught is the initial pressure or surface pressure, you can say the surface pressure. Surface pressure, you can pressure on the surface. So definitely let me write, if here pressure is P naught, at that depth what will be the pressure if this is depth z. So rho gz, so definitely it will be add. It will be the addition of P naught plus rho gz. So option A is correct for that. Now, a very important question. So before starting this question, I will take 5-minute break for water. अभी तो बात कौन है क्या Sure. If anybody will join, then fine. Otherwise, we'll move ahead. Okay, I will move ahead on the next question. The question is the fluid flowing in figure, this is the figure 1.3, has an absolute viscosity mu is equal to is given 0.0010 lb second divided by feet square. Now the specific gravity is given 0.913. Calculating the velocity gradient, we need to calculate how your velocity is varying with respect to y, and intensity of the shear stress. Also you need to calculate the shear stress. Intensity of the shear stress at the boundary and at the point 1 inch, 2 inch and 3 inch from the boundary. That is, you need to calculate shear stress at 0, y is equal to 0. If I write 1, 2 and 3 inch, that means here if this is 1, at that place 2 and that place 3 inch. Now assuming, first we need to assume the straight line velocity distribution. Your velocity distribution is a straight line like that. Your velocity distribution will be like a straight. So here is given 45 inch per second. Here is your velocity is 0. In this direction is your velocity. In this direction is your y. Now option B is the parabolic velocity distribution. Remember, option B is given the parabolic velocity distribution. Whatever we have discussed earlier, this is a parabolic kind of thing. This type of velocity distribution you need to consider parabolic. So here we are going to consider only half part. So this look like para. If you will, it will be look like that. Your parabolic. So for parabolic, we need to calculate the equation of parabolic and a straight line. So you know the equation of a straight line. First we need to consider the A. When we consider the velocity distribution A, you know already y is equal to what? Mx plus c. Here in this equation c will be 0. So y is equal to mx. X is what? Here x is at the place of x. Next direction we have u. So please try to think in this way. And for parabolic, what you will do? For parabolic, we need to write equation in the form of, because from the very basic, your parabolic equation is quadratic type plus by or bx if this is x direction, if this is y direction, plus c. If you want to write in the quadratic form, if your parabola like that, let's suppose from here, then it will be your a x minus h, that is how much distance from the edge, plus k, how much distance, this is the k and this is your h. So based on this we will try to solve this question, a very important question. When we consider your actually du by dy is what? Du by dy is what? It is that is how much change in the u direction with respect to y is nothing but is a slope. In case of a straight channel, in case of a straight velocity distribution, your slope will be constant. Your slope will be constant at every level. Here also, that is on 1, 2, 3, whatever the given is point, 1 inch, 2 inch, 3 inch. But in case of parabolic, at every point your slope is changing. So it is very challenging task to calculate the slope in case of parabolic comparatively your linear one. So these are the hints. Based on that, if you want to think, there is a very classical question which is correlate your previous knowledge. This question also correlate. So please try to think and try to give the answer. By the way, I have the answer of this question. No problem. I will explain very clearly how you will approach this question, how you will solve this type of question. Such type of question you can expect in the GATE examination or also in your final hydraulics examination, because this question is very classical, which is correlate your 10-12 knowledge, also your engineering knowledge here. What is joined till now? So today is a very important no one joined. So based on that, please try to think. So these things I have for your simplicity. Maybe some student may forget the equation of parabola, so for that I have written here how you will write in the vertex form, because here you have, if you will extend these things, here this is the vertex, you have the vertex value, how much, x value is 45, because from here to here is 45 inches given, and y value is 3. So if you want to form your equation, how you will form? U is equal to, that is U is equal to, how you will write? Because if you will see here, your U is a function of what? Function of y square, because this is the equation for parabola. If you want to correlate this equation, this parabola is look like that. If you will move ahead this parabola a little bit, you will take the above, if you will consider half part, so this will look like that. So your x is what? X here is u and y is your, this is the function. If you want to write like that, so your u is equal to what? A and y minus k. K is what? How much distance in the your y direction? So we have the in 3, then plus h is what? In the x direction, 45. So u is equal to a, and this is square. So you can write like that also, because when you will open these things, whether if you want to write here y square plus 9 minus 6y, if you will write these things, similarly will become y square plus 9 plus or minus 2y or 6y. So there is nothing hard and fast, and 45. So your final expression for the parabola is come like that. U is equal to a 3 minus y square plus 45. How you will calculate a? At y, your u is equal to what? At y equal to 0, here is y equal to 0 and u also is 0. So if you will put here 0 equal to a 3 minus 0 plus 45, it will come like a is equal to minus 5. So when you will put this equation, u is equal to 45 minus 5, 3 minus y whole square. When you will calculate your du by dy, it will come 45 minus 5 into 2, 3 minus y into minus 1. So finally it will come 45 plus 10, 3 minus y, du by dy. So your du by dy is come like du is comes out 45 plus 10, 3 minus y. At the place of y, at the place of 1 inch, that is when your y is equal to 1, what is the value of du by dy? 45 plus 10 into 3 minus 1, 20, that is your 65. What is the shear stress at that? Shear stress is nothing but mu into your du by dy at 1, du by dy at 1. So it will 0.001 into 65. You will get it very easy. So these are the whole expression how we will calculate the parabolic part, which is very challenging. If you will see the straight line equation, how it is changing, here I am going to write at y is equal to 0, your velocity is equal to 0. At y is equal to 3, your velocity is equal to 45. So if you will write your velocity is equal to 15y, this will be hold very good. Now you can calculate du by dy is equal to 15. So for a straight, everywhere at point 1, at point 2, at point 3 inch, your velocity gradient will be this. And what will be the your shear stress? Shear stress is equal to mu into du by dy. So mu is constant, this is constant, so everywhere your shear stress will be also constant. So remember, now I will show the solution for that. So it is written only these things. Your u is equal to 15y, whatever for a straight, we are going to first solve the straight line. So your du by dy will be like that, 15 dy, and dy by dy will be the constant, because here is, if here is let's remain, if will be y, then will be changed, here is nothing, so it will be constant throughout. So like that you will calculate your tau, and at y is equal to 0, that is at the boundary, velocity will be 0, and your this the gradient will be like that, everywhere will be gradient like that. So the expression tau is equal to mu into your gradient. For y is equal to 1 inch, 2 inch, 3 inch, your gradient, and your tau also 15 per second, and your 0.015 like that. But for the case of parabolic, your equation is like that, 45 minus 5 3y square, whatever I have previously I have tell, and del u by del y like that. Oh, here your 45, when you will differentiate, your 45 will be 0, so only 10 minus, okay, sorry for that, 10 minus 3y, it will be like that. Here I think some mistake, here some mistake. So it will be your 10 3 minus y. So it is 10 3 minus y. Now when you will put the value of y, then you can easily get these things, and when you will multiply with the tau, you will get the expression like that. So it is very easy, not very difficult, but try to understand the basic, how you will form the equation of the parabolic here. This is the challenging things. Now moving ahead on the next question. This question is also very important. Water is moving water is moving through a pipe, the velocity profile at some section shown in the figure 1.4 and is given mathematically u is equal to beta by 4 mu d square by 4 r square, where y is equal where u is velocity of water and any positions are and what is r is a radial distance from the center line. Remember, r is the, let me take the bigger one, r is the distance from here, not r is not the radius, or is not the radius, it is just representing your direction, this direction from the center line. Remember, or you can write at the place of r, you can write the y also. But when your r will be the radius, at the when your r will reach at the tip, that is at the wall, then your r will become the radius, but otherwise it will be not radius. So okay, and what is the shear stress at the wall? That is shear stress we need to calculate at the wall, at that place of the pipe due to the water. And what is the shear stress at the portion at d by 4? R is equal to d by, let's suppose here d by 4. If the given profile persists distance L, if the profile is having the distance L, what drag is induced in the pipe? You need to calculate drag also. Drag force. What will be the drag force? Your shear stress, and where is drag is acting on the surface. So surface area. So you need to calculate first what? Your shear stress. Shear stress you need to calculate. If the, okay, on the pipe by the water in the direction of flow over this distance. So your area you can calculate very easily. Area is nothing but pi dl. But here is very challenging thing, and you need to calculate what? Tau. For calculating tau you need, if I write here tau is equal to mu du by dy. So what is u? U is nothing but beta divided by 4 mu d square by 4 minus r square. When you will differentiate these things, du by dy, or here if it is r, so you need to write here r. So beta 4 mu is the constant. This will be 0 because here is not r. So sometimes people thinking about the d is related with r, not, and your r is equal to 2r. So it will become like minus 2r beta divided by 4 mu. You can write also r beta minus r beta divided by 2 mu. So when r is equal to what? D by 4, you need to calculate at the d by 4. So put d by 4. If you will put here d by 4, you will get what? D beta minus here 8 mu. So at d by 4, your du by dr will be minus d beta by 8 mu. Now you need to calculate your shear stress. When you will multiply with this your shear stress, you will get what? Minus d beta by 8. This is your shear stress. When you will multiply with area, you will get the drag. So this is the all calculation here. Minus beta d by 8. When you will multiply with the area pi dl, you will get the your drag things. Remember, whole things is very easy, but this such type of question you can get expect in the gate examination because it's a very classical question. I have selected very classical question from the books. Now moving ahead, this question is very easy. Please go through this question. If you have doubt, you can mail me. My mail ID, let me write again. OP Maurya IIT 14 @gmail.com. So you can write, if you're not able to calculate the answer of this question, you can write me mail with the screenshot of this question. I will definitely send you the answer. For your simplicity, I have written these things. And here, okay. Oh, by the way, I have given the answer for this question also. Please go through this. If you are not able to solve, then I will definitely will reply. This is a new type of question. A square block of weight 1.1 kilonewton. Weight of this block is 1.1 kilonewton and 25 mm and 25 250 mm on an edge slide down an incline on a film of oil 6.0 micrometer thick. Figure if you want to see the thickness of 0.6. The square block, it is a square block. So here is 250, this is 250, and if it is block, definitely it will be the 3D. So this will also your 250. Okay, your height will be the 250. So everywhere 250. Now, assuming a linear velocity profile in the y, here we need to consider what? Linear velocity profile. Okay, what is the terminal speed of the block? That is your speed of the block you need to calculate. The viscosity of the oil is, viscosity is given 7 Pascal second, meter Pascal second. So very easy question. But how we will calculate these things? So this is what? If this is weight W, so W sine theta, sine 20 degree, and this is resist by what? Your shear force, that is tau into area. So what is area? Area is nothing but 250 into 250 mm square. I mean it will come in the mm square. What is tau? Tau is equal to, you know already, mu into del u by del y. But here is the linear velocity profile. So velocity into y. Now it is very easy. Please try to think. Anybody is wine? I think no one joined till now. Okay. So how you will calculate these things? Oh, this is the solution. So how you will calculate your W sine 20 degree is equal to your tau into area. So tau is equal to mu, you know already. We need to calculate, and y into area is, hello, hello, okay. So Ratnasri, I am audible, please.
Yes, sir. Audible, sir.
Okay, okay. So we have actually solved the lots of problems. Maybe I think in between your network was not very proper. So we have solved such type of question. This is very, very important question. You can expect such type of question in the several examination, in the gate examination also, and your final exam of hydraulic engineering also. So now we are solving this question. Might be you are able to see this question. A square block of weight is 1.1 kilonewton and the side of the square block is 250 mm and the thickness of the oil is 0.006 mm, that is your micrometer in given in the micrometer, and your viscosity is given 7 meter pascal second. So how you will calculate these things? So for that, basically so you need to calculate here the speed of the block. So you need to calculate your velocity of your block, or you need to also say the velocity of block equal to velocity of the upper layer of your fluid, velocity of the upper layer of the fluid. So you know already, if you will do these things, your W sine theta and here W cos theta, and this will be equal to your tau, that is your shear stress, into a surface area. So surface area is nothing but 250 into 250. So here is your tau, and in the question is given, you need to consider the velocity profile is linear here. Your velocity profile is linear, that means you're like that. So if it is linear, so you can write your gradient term in the du by dy, you can write like that v by u. So your final expression is like that. So now what you will do, 1.1 kilonewton into, you need to calculate, if you want to in Newton, you multiply with the 100 into sine 20 degree, and dynamic viscosity is given 7, and I think it is in the given in the megapascal. Okay, and your velocity is, I think, in megapascal is given. Let me see the first. Yes, in the millipascal, I think. So you need to multiply with the minus 3, and now your velocity you need to calculate, and y is given 0.006 mm in meter. This is your minus 3 in meter, and our area is what? 0.25 into 0.25. So when you will calculate these things, you will get your velocity is equal to, that is 5.16 meter per second. So remember these things, very important. So now the next question is a surface tension. This is a very basic question. Okay. The surface tension of mercury and water at 60 degrees Celsius, that is your surface tension of your mercury Hg, and your surface tension of water H2O is given 0.47 Newton meter, and for water it is given 0.0662 Newton meter respectively. What capillary height changes will occur in these two fluids when they are in contact with air? When they are contact with air in a glass tube of radius is also given 0.3 mm, theta is equal to 130 degree for mercury and 0 degree for water. Your unit weight of mercury is given 3 kilonewton per meter cube, and for water gamma, for water H2O is given 9.650 kilonewton per meter cube. So if you know the formula for this question, you can easily get. So here you need to calculate your capillary rise and fall. H is equal to, so here is nothing but this is your, if you will write your R is equal to what? D is equal to 2R. So R is equal to D by 2. Here if you will write D, then definitely will 2 will be goes in nominator. So your 4 sigma cos theta y and rho z is equal to gamma. So if you will go through this formula, you will get the answer. Put the theta is equal to 130. Everything is given. So your height will be the in mercury minus 15.2 mm, and in the, that is capillary fall in case of mercury and capillary rise in case of water. Now the basic question is from the your hydrostatic. The first chapter we have finished, and the very classical question we have solved. How you will form the equation for the parabola. Now the question is for a vessel containing the glycerine under pressure as shown in the figure 2.2. To find the pressure at the bottom of the tank. You need to calculate the pressure at the bottom. How you will calculate? So previously we have seen the pressure, that is P naught plus rho ZD and rho ZH you can say. So using this formula you can get the answer. If anybody join, yes. If Ratnasri, if you want to give the answer for this question, I will wait 2 minutes for you. Then I will explain this question. I have lots of questions today. Maybe all questions, solution of the all question is not possible in class, but I will upload the all questions with solution. Please go through one by one. If you have any doubt in any question, you can mail me, and anybody can mail me, no problem. So now I want to give the answer. So the how you will calculate your 50 Pascal is given already. So your 50 Pascal will be here initial, and rho is, what is the rho for this glycerin? Okay, rho is not given. So what you will do? Actually, this is the standard value you can use the for glycerin rho. And what is the G? And H is given. G already know you 9.81, and H is 2 meter is given, and you can use any value of the standard value of the glycerin. In this solution, what is the standard value used? Okay, your standard value of the glycerin, that is your gamma value, that is rho z. Rho z for glycerin is 12.32 kilonewton per meter cube. So where you can calculate easily very. Now moving ahead on the next question, a closed tank in figure 2.3 at 20 degrees Celsius. Let me put it in the full view mode. Okay, you are not able to see. Okay, now if the pressure at point A is 98 kilopascal, absolute pressure is given. And what is the absolute pressure at point B? At the A, here is the pressure absolute is given 98 kilopascal. You need to calculate the pressure at B, absolute pressure. And what is the percentage error result from neglecting the specific weight of air? If we neglect this pressure, what will be the error? Whether 1%, 2%, 3%, or 5%, 10%. So please, very easy question. If you will go through from the very basic hydrostatic understanding, then you can very easily give the answer. So for this question, I will wait 1-2 minutes, 2 minutes at least, to try to give the answer of the first question. Then error part I will explain. If you are not able to give the answer, then I will explain with you after 2 minutes. Just please take a try. Okay, how we will calculate? Let me proceed. So here first we try to calculate, first we try to write the hydrostatic concept here. So pressure at A plus pressure at up to 5 centimeter. So rho of air G H is given 5. Up to here is water, up to here is water. This is plus, this is minus, it will be cancel out. So you need to write these things only. Minus, in upward direction we are taking the minus things. Minus rho of water H2O into G into your, this height is 5 and up to this, so it will be only 2, and this air minus rho air into G into 3 meter minus rho B. Oh, pressure at B is equal to 0. When you will calculate, you know already rho of air is 1.002 sometimes kg per meter cube. Rho of water, you know 1000 you can take. So when you will calculate your PV is equal to, let me show the answer. Your PV will come like 78.44 kilopascal. Now when you will neglect your air things, what is actually mean? When you will remove these things, when you will remove these things, so only what will be remaining? Pressure at A minus rho H2O G into 2 minus PV. So your PV will come little bit, maybe, yes, your PV will come out your 78.420. So very, if you will see your, in the first case 78.44, in second case 78.42, very minimal effect of your air. So we can neglect also this thing. When you will calculate error, so your previous value, error with respect to what? Error with respect to, I am going to calculate the previous one. If you want to hear, it's a very interesting thing. If you want to calculate error with respect to what? The current value or the previous value? If you want to calculate with the previous value, so with respect to, I want to calculate the error with respect to previous value, so you need to here minus from the previous value. That is your 78.42. So you can calculate, this will become. If you want to calculate with respect to, if I want to calculate what was the error in the previous value with respect to current value, so you need to write down here 78.402 and whatever you will be minus. This will be always in the, then you will get also answer. But answer will be definitely will be differ, because you need to calculate the answer with respect to what. So always remember, when you will going to calculate error, then always ask the question self, or in the question very clearly written, whether we need error with respect to the previous one or this one. So remember, sometimes in the questions, the question setter try to confuse the student and anybody. So now moving ahead on the next question. So the question is very simple. The mercury thing, in a, if in figure, if you will see, your specific gravity is given. Specific gravity is given for this is 0.84. Specific gravity of this is given 0. That is 1 is given. Maybe this will be water, and height H2 and H1 is given. It is very easy.
you can utilize this concept here, whatever I was discussed previously, this concept, you can get the answer for this question also. Very easy. So here is the answer. Now this is also very easy question. If the triangle of height D and the base B is vertically submerged in liquid with its vertex at the liquid surface, derive an expression for the depth to its center of pressure. This is only the formula things. How you will center of pressure. So your that is your depth, center of depth at up to the center of gravity, and you can see also Cg you can write plus moment of inertia with respect to Cg. So this type of equation here you can see very easily. So your H center of pressure is equal to hCg plus moment of inertia with respect to Cg divided by hCga. So you can calculate moment of inertia. What will be the BD cube by 36? That is your width, depth to the power cube 36. Remember. So it will be the 3D by 4. Now this is important question. A dam of 20 meter long retains 7 meter of water. 7 meter of water depth is retained and 20 meter long. This depth is, the dam is 20 meter long. That is, the length is the 20 meter of the dam. When you will look like that, it will be the 20 meter. So here water is retaining. Water is retaining up to the your 7 meter. This is all the water is here filled up to that much. So now the question is here, find the, so the length is 20 meter and depth is 7 meter is given already. Find the total resultant force acting on the dam. Total resultant force you need to calculate on the dam and the location of the center of pressure. HCP you need to calculate and the resultant force, total resultant force. So your resultant force is nothing but gamma H into area. So how you will calculate these things, I have given just hint. So if you want to take attempt, otherwise I will show the answer. Okay, no problem. So the answer for this question is force is equal to rho HA. So what will be your A? Basically for calculating A here it is challenging things. Not very challenging but definitely. So A is what? This area, whatever the area is, wetted area. This area is up to the depth. This area is the A. So area is what? 20 meter long. 20 into this width. 20 is this, and you need to calculate this length. What is the length of? You need to calculate the area of this one. What will be the area? This area. So length is 20. What is this height? So you know already this height is, here is 7 is given already, and this angle is given 60 degree. In this question here is given 60 degree. So you can also draw a straight line here. So this is also will be 7, because this 7, this 7. So your sine theta is equal to, sine 60 degree is equal to what? 7 divided by your hypotenuse. So hypotenuse is nothing but, if you want to write the name of this length is b, so here you will write b. Your b is equal to 7 by sine 60. So your 7 by sine 60. So like that. So your area is these things. Now you know already what is the gamma value is rho g. So this will be the, what is the h? H is nothing but the average height. H is nothing but the average height. Your 0, here is the 0 plus 7 divided by 2. 0 plus 7 divided by 2, 3.5. Average height will be considered here. So you will get the answer 5339 kilonewton. The center pressure, what? Center pressure is located at the 2/3 of the water depth of the 7 meter. How 2/3? Because if you will draw your center of pressure, it will be like, here is triangle, the center of pressure is the 2/3 of the your total depth of the water will be. If you will see above, yeah, above shape was the triangle, so your center pressure was around 3/4 of the total depth. 3/4 of the total depth. Here your, in case of this type of structure, the center of pressure is located at the 2/3, that means 2/3 of your depth from the top. So you know for the triangle, it is the center of gravity from the below, it will be 1/3, that is your, if this height is h, your center of gravity from the bottom, it will be h/3. So this is the 2h/3. Okay, now moving ahead on the next question. This question is very, very important. Find the weight of the floating in this figure, whatever they given. The previously we have solved already one question. What is the principle of buoyancy in the fluid mechanics? The object submerged in the fluid, the object submerged, that much object is submerged already, that much object submerged in the fluid experience an upward force equal to the weight of fluid displaced. Weight of fluid displaced. Force, how much force? Weight of fluid displaced. So weight, how we will calculate the weight? Rho g. And how we will go through this? Weight of your fluid. Oh, this is not the expression. So your formula will be like that. So how you will calculate? So it will be calculated like that. Your force of the buoyancy will be equal to the weight of your water displaced, and weight of the water displaced is nothing but your rho here. If diameter is d, rho g, definitely it will be the your unit weight of water into volume. So how you will calculate the volume? The surface area of this, surface area is what? Surface area of the below, so pi by 4 into d square, pi by 4 into d square into the submerged part of the body, 7. So your 1000 into 9.81 into your pi by 4 into d square, d is 0.08 square divided by into your 7 centimeters, so 0.07. When you will calculate, you will get this expression. And in the Newton, definitely this expression will give you answer in the Newton, so 3.44 Newton. So remember, this is a very important question. So similarly, we have the question like that, velocity vector if it is given, so how we will find the acceleration of the particle. So acceleration expression is nothing but d del v by del t u v w. So here u is equal to given what? This 3t, v is equal to xz and w is equal to. So you need to calculate your this type of, when you will calculate this expression, that is in x direction, y direction, in z direction, in whole direction you need to calculate. This is the your x direction acceleration up to that much. This is acceleration in the y direction, this acceleration in the z direction. So here up to that much is the y direction because j is here, and this is the z direction. So you need to calculate in the all direction. Then you can get very easily the answer of this question. So now moving ahead, this is also very easy question. So here the answer is given. So your velocity potential is given like that, your u is equal to ax square y square. So how you will calculate? If the velocity potential exists for the velocity field, so find out the, that is the find it means here the find out the expression for the velocity potential if this u v w is given, and also the plot these things. So you need to calculate what you know already, your u is related with, how related with your velocity potential. So using the expression you will calculate, then you will integrate this first equation, you will get the expression this that. But how you will calculate these things? So differentiate the equation 2 and 3. When you will differentiate equation 2 and when you will compare, you will get the your expression like that. Your del u by del y is minus 2xy. So definitely when you will compare, that is your f dash or f is constant, so velocity potential will be become, this is the constant. If c will be 0, you can plot your phi line at this figure. So please go through the each question one by one, definitely you will get the answer for this whole. I have lots of questions today, but due to the time constraint I cannot explain the whole question in the class. So I have lots of questions from the pipe flow, parallel pipe flow and everything. Open channel flow, venturi meter, and your from your this dimensional analysis and the jet, definitely. So this Moody's diagram and Nicorat's expression, what were the how the Nicorat get the expression for the roughness value, that is the sand roughness value in the pipe test. So remember all these things. So if anybody have any doubt, please mail me. I will be very happy to see your question in my mail. So thank you for today, and that is the whole thing from my side for this hydraulic engineering NPTEL course. That is, I have completed the 26 hour total 26 hour 12 week, and 1 to 12 week into 2 is the 24, and 2 hour extra session. So please try to if anybody have any question from any week and extra session, you can please feel free to mail me, and let me write again my mail ID here. So if anybody want to mail me, then easily you can mail me. My IIT OP Moria IIT14 @gmail.com. So easily you can mail me. So thank you for, and for best of luck for your exam, for your NPTEL exam, hydraulic engineering exam. So thank you all.